Welcome back, mathematicians. So our lesson today is on repeating decimals, and for that you're going to need two colors, a red and a blue, and then my black pen is going to be your regular pencil. So when we try to take a repeating decimal, we can take that repeating decimal and represent it as a fraction by creating and manipulating an equation and using algebraic properties to convert that decimal into a fraction. And so we're going to get started with our first example. For our first example, we're going to write 0.8 repeating as a fraction. So our first step is to define a variable. We do that by writing, let's say, let x equal, and we're going to let it represent the repeating decimal that we have. So 0.8 repeating. And that's going to be the equation that I use. So I start with x equals 0.8 repeating. And now I'm going to use my properties of equality, which says when I do one thing to the left side and to do the same thing to the right side, my equation is still balanced. And to separate those sides, sometimes it's easy to make a little line down the middle. Now the trick is to multiply both sides by a power of 10. So it could be 10, it could be 100, it could be 1,000, it could be 10,000. The way you know is if you have one repeated decimal, then it's going to be 10. If you had two, it would be 100. So as a side note here, we're just going to write that you multiply by 10 to the power of the number of repeating decimals. So in this case, I multiply both sides by 10. And by doing that, again, I still keep it balanced. I now have 10x equals, and because I multiplied it by a power of 10, this decimal and all these 8s get shifted over to the left. So I have 10x equals 8.8 repeating. It's still a bunch of 8s. All I've done is I've shifted it over, so now it's 8 point a bunch of 8s. And now I'm going to use the property of equality with my variable. So I let x represent 0.8 repeating. Okay. What I'm going to do to the left side is I'm going to take away 1x. You don't have to write the 1, but you can. And on the right side, I'm going to take away what x represents. So that's 0.8 repeating. And if I wanted to show that there are two 8s here, then I could say 2, 8, 8 repeating. It's just a bunch of 8s, right? Now when I do that step, I'm left with, on the left side, 10x minus 1x is 9x. And that equals, well, here's the trick. Because this is repeating 8s, and these are repeating 8s, all of those 8s are going to cancel. And I'm still doing my subtraction, so my decimal points line up. So I have 8 minus 0, and that just equals 8. So we have 9x equals 8. My last step, of course, is to divide by 9 on both sides. Those 9s cancel, and you get x equals 8/9. And that's how you convert 0.8 to, or 0.8 repeating to a fraction. On the left side of your book, I want you to do the following problem. So on the left side, you're going to write 3 problems, the first one of which is going to be to represent 0.76 repeating as a fraction. Our second of 3 examples is we're going to write 0.27 repeating as a fraction. So it's similar to the 0.8 repeating, but now we have 2 digits that are repeating. But it is kind of the same process. So we still define a variable. We're going to say let x equal 0.27 repeating. And then I'm going to create an equation and manipulate that equation. So I've got x equals 0.27 repeating. Remember up here I said that we multiply by 10 to the power of the number of repeating decimals. So here we have 2 digits that are repeating. So that means that we're going to be multiplying each side by 100. If there were 3 digits, it would be 1,000. And that's how that step looks. All right, multiply both sides by 100. And when I follow that step, I have 100x equals, and now everything gets shifted over twice. So 27.27 repeating, right? Because this is just 27, 27, 27, 27, and keeps going. And now I use that nifty algebra trick where I take 1x away from the left, and I take what x represents from the right. And when I do that subtraction, 100x minus 1x is 99x. And that equals, these 2 7s are going to cancel. And I have 27 minus 0, which is just 27. Again, it's really important that you line up the decimal points when you do your subtraction. You'll see why in the third and last example. We're not done with this one quite yet. We still have to figure out what x equals. So we divide both sides by 99. 99 over 99 is 1. So I've got x equals 27 over 99. And we can reduce that. A number that goes into both 27 and 9 is 9. So divide the top and the bottom by 9. And our final answer is 3 over 11. So 0.27 repeating is the same as 3 over 11, or 3/11. Our last example looks similar, but it is different. We're going to write 0.83 repeating as a fraction, but as a curveball, the 8 does not repeat, only the 3. So this is like, in a calculator, it would say 0.833333, right? Only the 3 repeats. But we're going to use the same strategy as before. So again, we're going to let x equal our whole number here, 0.83 repeating. Okay, so don't just let x represent the 3 that's repeating. We're going to let x equal the whole thing. And then keeping up with our trick, if you notice on this side here, we multiply by 10 to the power of the number of repeating digits or decimals. In this case, there's only 1 digit that repeats. So it kind of looks like you would multiply by 100 because you see 2 digits here. Only one of them repeats. Okay, so when I set up my equation, x equals 0.83 repeating, I'm only going to multiply both sides by 10. because I only have one digit that's actually repeating. If it was 0.835 and both the 3 and the 5 are repeating, then you would multiply by 100. We don't have it in this case though, so we're going to keep going with this. 10 times x gives us 10x, which equals, and now when I multiply this by 10, all I'm doing is I'm shifting it over, so I have 8.3 repeating. And now I use that nifty algebra trick where I take an x away from both sides, subtract an x, and then over here I'm going to take away what x represents. So x represents, and remember I'm lining up the decimals here, this is very important, 0.83 repeating. So take a look at what happens here. If this is 8.3 repeating, then I'm going to have another 3 here. And that's really important because now when I do the subtraction, these 3's all cancel. So I'm left with 8.3 and I'm subtracting 0.8 because this is 8.33333. This is 0.83333. All the 3's are going to cancel except for this one, right? Because we still have an 8 here. So we actually have to cancel those out. We have to do the subtraction. 10x minus 1x gives us 9x. And then we can't take 8 away from 3, so that becomes a 7, a 13. 13 take away 8 is 5. So 9x equals 7.5. And then we keep solving our equation. Divide both sides by 9. Those cancel. And you have x equals 7.5 over 9. This, while technically is the correct answer, we don't like to put a decimal inside of a fraction. It's called a complex fraction. So just off to the right here, I want you to put a star that says no decimals inside of a fraction. So to get rid of this decimal, we're going to multiply both the top and the bottom by 10 over 10. So we've got 7.5 over 9. Whenever I multiply anything by 1, it doesn't change, right? It doesn't change the value. 3 times 1 is 3. 6 times 1 is 4. But I can change the way on paper how 1 is represented. So 10 divided by 10 is also 1. So I'm not changing the value of this, I'm just going to change the way it looks. So I've got 7.5 times 10, which is 75. 9 times 10, which is 90. And then I can reduce 75 and 90. 15 goes into both of those. And you get 5 over 6. So 0.8 repeating, 0.83 repeating is equal to the fraction 5 over 6. If we go back here, I was giving you problems to do on the left side. The 2 problems that I want you to do are 0.76 repeating you've done. Now I want you to do 0.46, and the 6 is the one that's repeating, not the 4. And then lastly, this one's kind of a trick. I want you to do 0.9 repeating and see what happens.